Welcome back, Wolfpack. Today's lesson is on dilations, and hopefully after today's lesson and our follow-up in class, you'll be able to dilate objects on a coordinate plane. Let's get started with some vocabulary. A dilation is a transformation that stretches or shrinks a figure. So it stretches it, makes it larger, enlarges it, or shrinks, reduces it, makes it smaller, a figure. It changes the size of a polygon, but leaves the shape unchanged. So it may get larger or smaller, but it'll still stay the same shape. Therefore, dilations produce an image that is similar to the pre-image. It will not be congruent, but they will be similar. A dilation has a center of dilation and a scale factor, which together determine the position and size of the new image of a figure after the dilation. So it has a center of dilation and a scale factor. The scale factor determines how large or small the new image is. The center of dilation is the fixed point about which all other points are transformed by the dilation. Fixed point. Dilations involve multiplication or division, and the scale factor is the number by which a figure is multiplied. So to find the scale factor, you divide the image by the pre-image. So image is on top, pre-image is on bottom. You have a hard time remembering which one is which, I over P in alphabetical order, image over pre-image. If you multiply by, if the scale factor, if you're multiplying by a number that is less than 1, you're going to have a reduction, so a fraction that's less than 1. If you're multiplying by a number that is greater than 1, you're going to have an enlargement. If you're multiplying by the number 1, it's the exact same image, okay? So, about dilations. Properties of dilations. Dilations preserve angle measures. So, if the angle was 30 degrees before the image was dilated, the angle will still be 30 degrees after the image is dilated. Dilations preserve betweenness. If there was a point that was between two other points before the dilation, it'll still be between those same 2 points after the dilation. Dilations preserve collinearity. Collinearity means collinear. So if a point was on the same line as 2 points before the dilation, it'll still be on the same line as those 2 points after the dilation. Dilations preserve orientation, aka direction. If it's still facing the same way, then it's a dilation. Right? Dilations map a line segment of the pre-image to another line segment of the image whose length is the product of the scale factor and the length of the pre-image. So, what this really means is, aka, length of image equals the pre-image times the scale factor. That's basically what it's saying. Okay, pre-image times the scale factor. Dilations map a line not passing through the center of a dilation to a parallel line and leave a line passing through the center unchanged. And that doesn't make a lot of sense right now, but I'll show you an example of that in class. Okay? So, looking back at these properties, you can see right here, for example, preserve angle measure, whatever the measure of angle A was, that's the same measure of A prime. Okay? Preserve betweenness. If I had a point that was right here, halfway between point A and B, then there would still be a point right here, halfway between A prime and B prime. If there was a point that was laying right here on line AB, it'll still be on line A prime, B prime. That's collinearity. If you notice that A, B, C, B is at the bottom, A prime, B prime, C prime, B prime is at the bottom, facing the same direction, that's preserving orientation. So those are some examples of that. If you look at that second image, you can see that it's not facing the same way. Here C is on top, here we have C prime on the bottom, and you can see that even though they are the same width across, They are different lengths here and here. So it's not the same exact shape. It was changed slightly. Okay? So that's an example of not a dilation. This is not a dilation because it doesn't have the same orientation and it's not the exact size, exact same size. I'm sorry, it's not the exact same shape. We're going to do examples 1 in class. I like to explain this a little bit better. So let's go to actually example 3 first. And I have it on here called example 4. Sorry, that should say example 3. You work at a photography store. A customer has a picture that is 4.5 inches tall. So if she already has it, is that the image or the pre-image? That would be the pre-image. The customer wants a reduced copy. Reduced, so it's going to be, the scale factor is going to be less than 1, of the picture to fill a space that is 1.8 inches tall on a postcard. What scale factor should you use to reduce the picture to the correct size? So scale factor is image over pre-image. Okay? So what is my image? I'm going to want it to be 1.8. So I'm going to divide it by the pre-image of 4.5. And when you divide 1.8 by 4.5, you get 0.4. Using a calculator, that will take you to do that in your head. So the scale factor is 0.4. And yes, that is less than 1. Okay? A reduction means you're multiplying by a number that's less than 1. So that's finding scale factor. One number divided by another, there you go. That's the answer. Example 2, tell whether each dilation will result in a reduction or an enlargement. Then find the coordinates of the image using the given scale factor. Scale factor of 2. Well, scale factor of 2 is greater than 1, so that would be an enlargement. Okay, so we said whether it was an enlargement or reduction. Now we have to apply the scale factor to all of our points. Okay? And you do that by simply multiplying each coordinate by the scale factor. So our scale factor is 2, so 2 times 2 is 4. 0 times 2 is still 0. 0 times 2 is 0. Negative 2 times 2 is negative 4. Negative 4 and 2, 2, and 4. Okay? And it did not say, our directions did not say to graph it, so we found the coordinates. Let me graph it really quickly. 1, 2, 3, 4, 0, 0, negative 4, negative 4, 2, and 2, 4. And I think I might be wrong. Let me just double check really quickly. Negative 4, 2, and, oh, I did. This one's wrong. I'm sorry. And 2, 4. There we go. That looks better. So this is what it should look like. Obviously, drawing it straight up as possible. There we go. And letter B, scale factor of 1/4. Well, we're multiplying by a number that is less than 1. So that would be a reduction. And to find the new coordinates, we're going to multiply everything by 1/4. So 4 times 1/4 is 1. 8 times 1/4 is 2. 6 times 1/4 is 6 over 4, which reduces down to 3 halves. So 3 halves, 3 halves. 6 and 4 multiplied by 1/4 again is 3 halves and 1. And then 4 times 1/4 is 1. So smaller numbers, reduction. Okay, I'm going to kind of plot this just a little bit, but it's not going to be perfect because we're working with fractions here. So 1, 2. 3 halves, it's 1.5. So 1.5. 1.5 would be about here. Three. So 1.5. 1 would be about there. And then 1 would be here. You can see that's making it really, really small. And if I try to even plot those together, that might not even look right. But there you go. Okay? So same exact shape, way different size. Okay? Hopefully that makes sense. Really, basically, what you're going to need to be able to do is find the scale factor or use the scale factor. If you can find the scale factor and or use the scale factor, you'll be all set. Have a great day, guys. See you next class.